Okay, so our presentation is about the coastal range, which is in California.
The coastal range is a geomorphic province that spans 550 miles from Humboldt County and lasts all the way north to the foothills of the Klamath Mountains. A geomorphic province is defined as a naturally formed geologic region that shows a distinct landscape or landform. The Coast Range is home to metamorphic, igneous, and sedimentary rocks, as well as containing many diverse geological features. These geological features range from beaches and lagoons to volcanoes and mountains. And throughout our presentation and virtual field trip, we hope to teach you all about the wonderful coastal range of California.
Oh, that's the last slide. And the types of rock in the coastal range. So to start off, let's go over the three types of rock. First, sedimentary. This type of rock is made from pre-existing rocks, fossils, and animal remains. The second type is metamorphic, which are made from other rocks that are put under intense heat and pressure. And finally, igneous. Igneous rocks are made when molten lava cools and solidifies. There's a lot of basalt rock on the coastal range. Due to the coastal range being right up against an oceanic plate, it makes sense that there's a lot of basalt. However, there's also some granite on Point Reyes. Granitic rocks form due to slow melting magma under the earth and are later revealed by erosion. The coastal range has a wide variety of rocks. A lot of the rock has layers due to its closeness to the sea. And also most of the rock was formed in the late Mesozoic age, which is about 100 million years ago.
All right, so some geographic landforms. So the wildly diverse coastal range is home to many geologic landforms. For our presentation, we'll be focusing on the four major geographic landforms of the coastal range. Firstly, a terrain is defined as a fault-bounded area or region with a distinct structure and geological history. These terrains are constantly found throughout the coastal range. The Napo volcanics are once lava-producing landforms in the Santa Rosa quadrangle of the coastal range. These volcanoes contributed a large amount of the igneous rocks found in Santa Rosa. Point Reyes is home to a large amount of igneous rocks, specifically granitic rocks. This differs from the rest of the coastal range. The coastal range is primarily basalt and not granite, but the Point Reyes is different. Why, you may ask? This is due to the formation of the San Andreas Fault and years of erosion that take place. Finally, the Franciscan Formation, a common rock formation in the coastal range. And this formation can be found nearly everywhere in our province and is home to heterogeneous rocks that line the coast.
Okay, and some of the plates and faults in the coastal range. So there are multiple large geographic features on and off the coastal range. One of the largest and most well-known is the San Andreas Fault. This fault was created 30 million years ago due to the Pacific Plate and North American Plate meeting. Before the plate was created, the Farallon Plate was one of the largest in the area. The plate is long gone, though, as it subducted under the North American Plate before the San Andreas Fault was created. Shown above is a diagram of a subduction zone. The San Andreas Fault brought in a lot of deep-sea rocks, such as chert, but also brought in rocks like quartz that were deep under the surface of the earth. The San Andreas Fault grows 1.4 to 2 inches per year. Another large geographical feature is the Juan de Fuca Ridge, which sits roughly 700 miles out to sea. It's where the Pacific Plate meets the North American Plate and is a massive rock spreading center for rocks. The Juan de Fuca Ridge is the closest mid-oceanic ridge to California, and it's the cause of lots of igneous and metamorphic and sedimentary rocks being brought up from the depths. Okay, so for our virtual field trip, we decided to focus on the Marin Headlands due to its diverse geological landscape.
So zooming in, focusing on Rodeo Beach. Rodeo Beach was formed 5,000 years ago when the sea level rise slowed after the end of the last glacial period. Rodeo Beach is home to three Franciscan rocks. These rocks include chert, basalt, and sandstone. Chert and basalt are usually found on the south side of Rodeo Beach, while sandstone is generally found towards the northern portion. You can distinguish these rocks based on certain characteristics. For example, chert can be diagnosed by its hard, thin layers. Basalt is noticeable due to its pillow shape that stands out from surrounding rocks. And finally, sandstone can be identified by a stark grit and metamorphic overprint. Rodeo Beach was formed by convergent plate boundary, where the Farallon Plate was pushed under or subducted underneath the North American Plate, and this process formed igneous, sedimentary, and metamorphic rocks.
Okay, so the headlands are also home to all three types of rocks: sedimentary, igneous, and metamorphic, specifically chert, schist, and basalt. Chert being sedimentary, schist being metamorphic, and basalt being igneous. Chert is one of the most prominent in the headlands, and when looking at Rodeo Beach parking lot, it's pretty clear. It's a red rock formed from fossilized plankton at the bottom of the ocean. It rose up to the surface and is predominantly a coastal rock. Schist is another rock that is visible in the headlands. Schist is found on the far side of Rodeo Beach and is semi-gray and tends to have some visible folds. And finally, there's basalt. Basalt is found around Rodeo Beach, but not on it. In order to find basalt, we can look at the sea cliffs all around the headlands. Basalt is mainly organized and is one color, which is dark gray.
One of the most unique things about Rodeo Beach is the sand. Rodeo Beach doesn't have ordinary yellow sand you can find at most other beaches. It is larger grain red and black sand. The sand is more like pebbles on Rodeo Beach. The red comes from all the eroded chert, and there's also some green chert and cornelians, which are lighter and orangish. All of the sand got there from eroded chert and other rocks off the cliffs around Rodeo. There's also a large lagoon, which is separated by the sand of Rodeo Beach. The lagoon formed from a massive glacier and was eroded the whole valley and landscapes. There's not much soil and there's a lot of eroded rock. This is exactly what you'll see in Rodeo. However, since the glacier was so long ago, there's a decent account of soil that has come into the valley.
Thank you. Does anybody have any questions? Thanks.
Yeah.